David, it's a pleasure having you here. You're building the world's fastest, smartest, safest, and most accurate robot in the world, which is pretty ambitious of you. And there's just so much I want to talk to you about. I want to talk to you about the features, the sensors, the accessories, your vision with NEURA. Before going into all the technical aspects of this, I really want to know about you, and I think the community can also learn a lot about your journey. So, can you take us through your process of kind of your life journey that led you to start and become the CEO of NEURA Robotics?
First, like after high school, actually, I was not. I studied engineering and
Okay.
actually doing like, but more in the automotive, doing like casting parts for motors and things like that. So it was more like really something nothing to do with robotics, which I really also enjoyed. It was cool. So I was mostly designing some new motors for Mercedes, Daimler. And but it did not really fulfill me. So after that, I was actually going to United States to spend some time there as a social worker. So it's something completely away from engineering, from like just doing something for other people or doing like helping people on the street. So I was working as a case manager for homeless people, for people which are coming out of the prison, and my work was actually to build them up again. So I was also leading like AA meetings, NA meetings, to somehow get them back to life. And I also really enjoyed this work, but it was also something which I felt is amazing, but also a little bit because I was not really studied in. So I was not really prepared for that, I would say. I just took everything too close to my heart. So that's why I also, after 1.5 years there, I decided to go back to engineering or finding something which is really fitting maybe this both worlds, both passions together. Right? So this when I actually also went to Switzerland, where I found like an amazing company. So it was actually yeah, older boss of a company, machine building company, which were also successful. They were market leader in this segment where they were working in, and he just wanted to, in the end, like of his work time, he thought, okay, to do something more like crazier, something which is more innovative, something because he has two sons and he wants to have like two companies which he can give away. So and that was actually my opportunity. So he like I applied there and he invited me. I had also already a job at Formula One team in Switzerland to also as a designer for aerodynamics. But on the way there, I thought I would just check into this company just to see what they are doing, right? And because the work description was actually not really clear, because they were talking about some machines, building machines, but also making something innovative, something new. So this is why I thought, okay, good, let's just check in. And when I was there, I saw that's a company I want to work with. Because he was not really knowing what he wants to do, but he thought about 3D printing and robotics, something innovative, something which can change the world, also something which is new, or where we can really put some thoughts inside and change something. So yeah. And there we started with robotics because it was clear that even robotics can be in 3D printing one day. So we started with robots. So I never touched a robot before, and I was starting to design a robot. We were a team of 3 people in the beginning. We started 2, but then later we were 3 people. And 1 year later, we presented some crazy products already onto market. And everybody was like freaking out because they thought we are already doing it for many years, but we just did it in 1 year. So there we actually figured out that it's cool what we were doing. And there actually also my passion for robotics started. And but in one day, yes, after 7 years, I think we did some crazy, the most accurate robot in the world and things like that. Big deals with Siemens and other companies. But still, there was something I want to do more. I want to do something on my own. And the other is I want to do something a little bit more crazier, because mostly if I put some thoughts in, like something about what I want to do, the people mostly started to tell me, okay, let's do it maybe in 5 or 10 years, and I don't want to wait. And that's how actually I was looking for some good investors, and I found a very good one, which were also sharing my passion, my dreams, and that's how I started. Actually, the company with the best team in the world. Yeah, that's.
The-
I hope I did not take too much time for that to tell, but it
oh,
was actually an amazing. Yeah, it was an amazing journey. So in this time, I actually founded about three companies. There was one like a robotics company. The other was a 3D printing company also, and one other was just an automation company which used robots to automate. And yeah, and now
that's
NEURA
cool.
Robotics.
That's cool. So that's how the story of NEURA Robotic basically started. You mentioned in your basically everywhere where you're on the media, you're always talking about how robotics have really not evolved in the past basically 100 years. You know, there was the Industrial Revolution where robots were doing very repetitive types of tasks. And ever since the growth and innovation in the robotic industry has been very linear. It's been, you know, maybe a bit faster, a bit safer, a bit more energy efficient. But then here you come in and you're like, this has to end. You know, there's an opportunity for a new market breakthrough. So what is that breakthrough you're trying to create in the market of robotics?
Yeah. Actually, yeah, the everybody like I was listening already since like 10 years to people which are talking about making robots our assistants. And also like since 100 years, actually, we are saying, okay, they're there to assist us one day, even like about even in the very long history behind, they were already talking
Yeah.
about robots as assistant or something which is helping us, something which is really there to make our lives easier, but I was not really seeing the step there. So I just saw, okay, good. There's one step coming now with the cobots. So robots are now able to work with humans, but still they're like going into humans. So they're hitting a human to know that there is
Mm.
something, but still there was no sense or something to really understand it's a human. So I thought, okay, the thought of like the company also, and my personal thought always was, how can we really interact with a human without knowing that there is a human? So this is actually the first
Mm.
sensor we were also developing, like figuring something out, which is actually knowing that's a 100% a human, and now I can safely interact with it, or and that's not a human, so I just keep going, or and that's actually the first sense we thought is the most important one. And then there's also others like how can you interact like or help somewhere without actually seeing something, hearing something, without even having a mind, or and that's
Ah.
actually until now was everything programmed. So it's very difficult to get a product somewhere home or somewhere. You will never see a product like a robot or assistant here at home, in your home, if it's difficult to program. Why should we have it then? Or there's no science behind. So there need to be somehow first the senses, so to know the environment, perceive the environment, and then we need something which is actually reacting on the data what you're getting and making own decisions to really be like useful, or to be actually something which is able to just when I ask like for something, it brings me. So there's many things which need to be enabled to make this one happen. And that's actually also the first steps we thought, okay, we have to change that. And there is already many things in the world and also in the developments, like where I saw in institutes and everywhere, which is already there. So why don't we just take this one, what's there, and also create something which is still missing? So we're concentrating on these things which are still missing, and then do something great out of it. And that's what we did. And yeah, I can even later show you maybe a video, and
Yeah.
also uh, tell you a little bit also here in this interview, maybe like the podcast, like a little bit about how actually we are doing it and what the robot is already able to do.
Yeah. That's exactly what I want to get into next. But before going into that, I think it would be interesting to define what's the difference in terms of definition between cobots and robots. How do they work differently?
Okay. A robot is that what I think the most know in the industries, or there's like the big heavy robots. There are also smaller ones, but they don't know like they cannot work without fences. So it means they don't have a feel of touch, or they don't have a reduced torque to make it clear. Or so it means like they don't have any force torque sensors. They don't have any limited torque like by current or something. So they don't know if they hit something, they just go through with the full power. So it means actually if you're working with them, they could kill you. And the cobot is actually made, so there's many norms for that, to really interact or working, not interact still, working next to humans without killing a human. That's actually the definition for a cobot. Right? So they're just much slower. That's actually the disadvantage of a road. They should be fast, but they are not, because they could be a human around, so they don't know it. Right? So that's why they're reduced speed, they have reduced torque, and then they're driving like and interacting. So it means when they hit you, they will not hit you as much that you get like anything. So nothing happens, and that's actually a cobot. But still, very, very difficult to get it to market. And that was actually also one of my thinking. How can like cobot have success if there is no possibility to really bring it to market? Because mostly the norms, they define like many things, like, okay, how much pressure is allowed to on any part of the body. But if you have a knife, or if you have something which is really like has some sharp edges or something, you are not allowed to use it actually. And every industrial parts, like if you look at a rare parts, you cannot not wish your rare parts or something. It's not possible. So this is why I still think there is still a very big gap, which is there's still many things missing, and that's actually a cobot.
Yeah, that's actually super interesting, and it's making me realize a lot of things. I'm currently reading this book called "The Future Is Faster Than You Think" by Peter Diamandis, I believe. A great book, and basically the idea of the book is that the breakthroughs and innovations that are happening in the 21st century, being in robots, in healthcare, in AI, they're happening because there's a convergence of different technologies that previously were separate. And now what's happening is that their convergence, when they converge and they meet and they unite, this convergence creates a breakthrough. So for example, for cobots, when I think about it, it's really a convergence of so many technologies that weren't really there 30 years ago. You need to have an AI in your cobots, which we're going to be talking about, that learns and understands from its environment. You need advanced sensors. You need, of course, the robotics and the mechatronics that go into the robots to make the movement smooth and fluid, and the accuracy and all those things. So I think that's actually does bring us to the different features that you have in your robots. What makes the NEURA Robotics cobots special in terms of features compared to what's out there on the market?
Mm-hmm. So this is why we actually even don't call it cobots anymore. So cobots is actually our low-cost version, like something which just has to reduce torque. But we have actually something new, which we call the new era of robotics, and we call it a cognitive robot. So it's not just cobot; it's really like cobot is like collaborative robot, and we are talking about cognitive robots. So it means they have like they are able to interact with the environment, and they also perceive the environment. And that's actually, so if we're talking about our new product has actually also the senses we humans have. So it means you can really talk with MAiRA like in a natural way. So you can really tell her things. You can also ask her how she's doing. So normally she says it's good. She even see like if there is more people around, so she will just say like I'm shy of in front of all these people and things like that. So it's like cool, but normally like the sense of the voice, like, or the sense of hearing. That's actually really something we are mostly used for. Or if you're interacting with the other human, you're mostly talking to, and that's the same. So you can really articulate or with MAiRA. You can also she has the sense of seeing. So it means she has cameras inside, and there is some more cameras. So she really see the whole environment. and she sees actually exactly where she goes to. And that's actually also something which enables her to make like own vision task. Like it means now we are combining, like, we are speaking, so it is like articulating and also gesticulating by gestures. Or so this is actually something, so you can really point on something and tell, hey, MAiRA, this part needs to go there, and she will actually
Oh,
make decisions on, but you don't have to program her. And that's actually that's the AI behind, and that's actually, you don't have to program her, because she will actually look at this part and know already, okay, what's the best way of grabbing this part. That's actually already a very big decision. It's already a very big part, which sounds easy, but it's very not so easy. Or it
I'm
depends what
sure.
gripper you have. It depends how the part looks and whatever. So she will take the decision and take this part and bring it really there. And that's already, you're combining two things. And then you have the sense of touch. Or so it means also when she grabs something and she feel like, okay, good, she already knows how much weight is there. So it means she also already calculating like the new path trajectory, like with to still stay accurate, because even if it has some different weight on the TCP. And there's many more. So that's actually the ability and also the thinking behind. Or what we actually created now is like we MAiRA can actually scan the whole environment. So it means you can actually put her in a new room and then tell her that's your new home, scan your home, and she will actually scan the home, your whole home. So you can actually have the whole environment in the real environment, in the virtual environment. And that's a cool thing. And then you can also simulate things. You can do things, that's for industrial. But we are thinking further, because we also think about cleaning robots. Or if you have a robot which goes into your home and then scans the house once, and then you can just let her walk like every hour around, and she will see everything what's coming new into this home, or something which is laying not there, which shouldn't. She will just clean it, or she will just pick it and put it somewhere. And that's actually, it sounds like a dream, but it's possible already. And that's actually what we do.
What about the AI part of this? To what extent can MAiRA learn about her environment?
So mostly she learns like, especially by grasping, or she learns a lot, because first we teach her like what's the best ways of many things. So where we have machine learning algorithms behind, so we always tell her yes, no, and she learns and says, okay, that's good, that's not good, that's good.
Mm-hmm.
So first you have actually to learn her what's good, or that's actually the thing, what's good and what's not good. And that's what we did actually the first time. And now she's actually able to grasp things. But if you're like having like a bottle, or like if you have a bottle, and MAiRA takes this bottle, or you see us by taking it, so you can let her learn by human tracking, and that's actually the cool thing. So you take something, so it actually takes your hands, so it knows actually that's your hand, that's a gripper of her, or that's how she would learn. Then you see a bottle, then she will actually, and then you say, okay, learn. Then you take the bottle, okay? She knows already exactly where it is. You can even let her deeper learning, but this is actually a little bit something we are still working very hard on. So where it also see, okay, the bottle is now shaking maybe front and back, so it's not a good position. Maybe this is the best position. This is also not so good because down there is shaking. Or so it also, and that's our things. This is why we integrated actually these base cameras, which are actually watching the front and also seeing what the human does. It does is see like the gestures, but also see like and learn from them, or like how we are doing things. And that's still, I would say, a lot of data. So always when I say things like that, my AI team always, they're more the like these guys which really love to do the things, and they are also doing it. But always when I already talk outside about it, they're like, oh, it's not ready yet. Or so there's a lot of things because too much data right now. And right now there is not really the computing power actually on the robot to really solve all the things. So if we are doing this kind of learning, we are using actually external, very high-tech computers. But if you're doing like standard as a product, which is actually now commercialized, actually, we have also many small learning algorithms on. There we have already a very strong GPU and CPU to learn from the environment, but not as much as I told you right now. So there we mostly just seeing, okay, there's a part, I grasp it, and if I find, okay, it's not good grasp, I know the next time, so it learns from itself. Or next time I know, okay, it's not good position for taking it. So that's actually how we are doing right now. So not really from humans, but it's actually right now the step what we are mostly working on.
This is so futuristic. I can't even believe I'm talking to you right now.
I also can't believe it sometimes because we didn't know in a very. That's why, like, I have really the best team. I can really say, I don't think anybody in the world could do it. I'm very sure actually. We really have the best hardware already, so it's more accurate than any robot in the world. So we have like accuracies there in microns, so it is about 6 to 10 microns. It's no robot is as accurate, but also from new machine learning algorithms like neural network behind, which is learning the inaccuracies and also know, and even over time will stay accurate, not like robots normally.
There's something, I have a question for your hearing and speaking capabilities for the robots. Did you develop your own natural language processing algorithm, or did you license the Amazon or or Amazon Alexa or Google API for that?
Mhm. So we are actually using right now three different. So we have one which we're working on ourselves on, but we are also using two different ones right now in cross-check. So we're working on two. They're actually open source. We just did like a further development on them, and we're using them like in cross-check, and that's actually is a great thing. So I hope I did not tell any secrets, but I don't know. But I hope everybody has a good voice control. So we are doing like really a great job, even like in very loud environments, because most people will say, "Hey, it's industrial robot." An industrial environment will not work. It will work because we also know the distance of the voice, and then we are mostly trying also to put everything around, like put the noises down and also just take the voices up. And yeah, so
That makes sense.
they're doing a great job there.
Yeah, that makes total sense. Your second product, which is not really your second product, it's something that complements your MAiRA robot, which is the your MAV, which stands for Mobile Autonomous Robot or Multi-Sensing Autonomous Vehicle. It's basically like a platform. It's like if you can imagine it for the people listening, it's like the platform of a tank, basically. Just the platform itself, but miniature. I think it's like 1 meter tall, and it's a platform on which you can install the MAiRA or your other robots, the Lyra, and then all of a sudden the robot becomes like a living creature where it can move itself. It can travel. It can go to the kitchen, get you a water bottle, and come back to you, or it can go to the other side of the factory and pick up some parts and come back to you. Can you tell us a bit about the MAV?
Math, yeah. So special about math is actually, so it's fully autonomous. So it means also you don't need any magnets or some stripes or something. So it's really you're also like making a card by also going once through the environment, or you can also load in a card. It's like up to you. And then actually, so that's actually not super special. So it's a standard AGV or AMR, like, but the special is actually that we're using also the AI from MAiRA actually, and also the camera sensors and also some other human detection sensors, also into in the MR, or to make it more smart. And that's actually the good thing. So it means you can actually have it like scan your room, like, or your even your complete home, and then and you can give math just like some advice where to go, and go there, pick some things up. But I think and this is actually just a mobile platform, so mostly designed for logistic reasons, right? So we're doing with this actually, the plan is to revolutionize also the manufacturing production lines, or so it means until now Henry Ford did a great job, or and he has kind of like invented the production line, so you can build many cars. But the only bad thing about it is actually that you're not flexible. So it means right now everybody like has a new wish of cars and things like that. So you need to be somewhat flexible. And the other thing is they're doing like mostly every year like maybe 2-3 weeks vacation, like the whole company. And why is it like that? Because there is no other chance to actually maintain the whole production line, all right? Because you can just stop it completely. You cannot stop it like just partly or something, because nothing will work anymore.
Sure.
And for that, actually, the solution is also using AGVs or AMRs, like the autonomous vehicles, which you can put also cars on. You can really be completely flexible in your in the whole production line. And also, like if one of them has to be like maintained or something, you just take one out, and the rest can just keep going and things like that. So, and there's many advantages in that region, but also for sure, just robot arms will not help you to really be flexible. Right? So also you need something which like legs would be the best. So, but at this time we're not there. So we're working on, but we're not there yet. And so we are using wheels, right? And that's actually the math. So it's the wheels of our robots. And there we also created some cool combined products which having like a shelf on it. So it means you have like a shelf, you have like also linear access on it, and then the robot can actually load and unload the shelves. So it means also with the abilities of MAiRA, you can actually go through a store, and you can imagine like the future, the store, you don't need to go inside, even like in this crazy times like now, you don't even need to go to inside. So the robot can actually go, you just click maybe in an app like what you need, and the robot just go through the store and picks up everything you need by vision, by all the sensors it has, or and you just get your groceries out. And that's actually something for the future. So the pandemic hopefully ends one day. So we are not talking all the time about pandemic, but we are talking about maybe having saving time. Or not everybody loves to go grocery shopping like me. I hate it, actually. That's why maybe I'm the fan of this. But maybe there are some people they love it, so they could still go in. So they're even able to interact with humans. But yes, there's many ways for use of a mobile robot.
That's awesome. That actually brings me to this. I had a few questions about the real life applications of your robots, and I think that could tie into to the grander vision of robotics and the way the robotics industry is heading, and how it's going to complement and disrupt different industries. And here from from one of your PowerPoints that you had on your website, there's a few industries that are mentioned, which I'm just going to mention, and maybe you can add on top of those. We have, of course, obviously the manufacturing industry. Then we have the healthcare, personal assistance, life science, the food industry, and the education industry. How, if you could give us practical examples, how would you see a robot come in and add value to each one of those industries?
Okay. So manufacturing, I think the robots are known there, but our new cognitive robot will be able actually to do more complicated tasks. So it means also it can assemble parts on each other, like by seeing it, by being just more flexible, and because it's also force controlled, it's also like super accurate. It's even you can ensure the quality also, because a human cannot like give you exactly the torque out what it assembled or something, but a robot could do it. And also just a much easier way of getting programmed. So it means until now it was programming. With our new product, you can just actually give advices to the robot, and the robot will maybe assemble some parts, maybe just pick and place parts, maybe like many kind of applications there, but mostly like pick and place, or bringing parts into machines, or bringing parts out of the machines, or also assembling them together, and many things like that. So then healthcare, it's actually a very interesting sector for us right now, because even here we sold already about 1,000 robots right now for healthcare companies. So here in Asia, there we are working actually on different kind of applications. So there's one which is for ultrasound. So it means our robots actually just go and do like a ultrasound check. One is like on breast for breast cancer. So there's also then AI features behind which actually recognize it by themselves if there's something. And the other is like even for pregnant women. So it means actually the robot goes there, has a sense of touch, and really makes actually the perfect picture or of your stomach and also
Mm.
everything inside. Or for pregnant, but also for non-pregnant. So you can even have in the future a very low cost, complete full body check by having just a robot scanning you completely also from in and outside. So this is actually one. And the other is also like for sure very interesting for us is like the surgery, but this is actually always taking time because there's a lot of certification needed and because you're going into the body. But it's also super interesting because we have there also different thinking of you can actually now just scan the whole body because it's under narcos, so you can really go there and it will not move the body, or so you can scan, you can open it, you can have very precise cut, and you always know exactly. And from outside you can just not like now, because right now we do remote moving, you know, like
Mm-hmm.
the surgery. Um,
Telesurgery.
robots right now, they are not really moving autonomous, and that's actually what we are actually creating. We could actually have autonomous surgery robot by just telling, okay, give them you have the body there scanned, then give a cut, you know, like maybe from there to there, it has to be that long, it has to be that deep, it has to be whatever, and the robot is super precise. It normally does not make any failures. So it means what I say normally is we are having there always a redundant, you know, it's redundant. Okay, that's the right. So it's a redundant. So it means it has dual channel always of every decision it makes, and that's why it's safe. Or we have the safest robot because it is able to every sense or everything what we're really programming or doing, it is redundant checked. So it means not just checked, it's also mostly dual channel and also mostly diverse sensors or something like that to make sure that we are making the right decision.
Mm.
And that's actually the other, and also for sure in recovery, like something which like in the recovery sector where we have like maybe a broken arm or leg or whatever, and you have to slowly recover, or we can just have much fast recovery by having the right movements or by having the right and that's actually also possible with the robot. So the robot could actually take your hand and then bring it first into the best positions. That's one thing, and also bring it like force control. So it means also it will, and you can also talk to it. So you can say, "Hey,
Mm.
it hurts" or whatever, and the robot will understand and maybe reduce the speed or stop or whatever. So there's many things like that. That's the other thing. So what else? Logistic. There actually
Logistics.
is for sure. So there with the new AMRs, they're just more flexible. Also have more AI inside, so it means they can actually really see, okay, there is a free spot. They don't have actually to be really like programmed, or they don't have to really run with a very complex, how to say it, very complex system, you know, where manage that. The robot can actually manage themselves, you know, it sees there is a free spot, I bring it there, then it also remembers I brought it there, or and things like that.
Mm.
So there's many other things which you can do with. And yeah, for sure, the future of shopping, everything there. Like
Yeah.
if you go shopping, the robot can actually go through the whole shop and do grocery shopping for you or any kind of shopping. And really, you can even put the parts everywhere inside without telling actually a complex system. And the robot will just go like we shop, or it will just see, okay, it scans just much faster than we do, and then see, okay, here is something I need, I take it out. There is something I need, I take it out, and this is like the future of robotics.
This is so interesting. This is really interesting. David, you did a great job. You did an amazing job. David, where can people learn more about your company? And what should they expect in the next few months in terms of new products or new announcements?
So they can for sure find us on LinkedIn, also on our webpage, so neura-robotics.com. And yeah, they can always ask me also personally. I'm mostly trying to answer as fast as possible. It's not always as fast, but I try. And yeah, so about the products for the future, I mean, the next couple of months there will this product I was talking right now about. So the cognitive robot MAiRA will come out. and they're actually, I think, about in February we will really publish it the first time. So we publish the whole product. We also publish our online shop and everything in end of February. Also in March, like the first release robots. We have already some in the market, so it's not just completely new. We have already customers which are working under NDA with our products to get also experience from them. Yeah. So, and for sure, I mean, this everything what I talked about, we did actually in a very short time, about 2 years, and now you can imagine what we do in 5 years, sir. And our work is to make as soon as possible a real assistant, something which is sitting next to us and asking us what we need, and we are having a more relaxed life when we are coming home, and that's actually the whole goal in the future. And I'm very, very certain that we will achieve it like as soon as possible, and we are working hard on it.
I can tell. Well, listen, David, you have my support and the support of the entire worldwide engineering community. We're excited to see how you're going to progress and how you're going to be changing the world. So thank you for being on the podcast.
Thank you so much, Liam. I'm so excited about it.